Section 3.6 is on page 228, talks about transformations of functions. Graphing is crucial in our class. There are 6 main graphs you want to familiarize yourself with and make sure you know how to graph. Y equal a number, y equal x, y equal x squared, y equal x cubed, y equal radical x, and y equal absolute value of x. I'm gonna show you in this section how to sketch by picking points, and then I'm gonna come back and give you another section and show you how to graph just by looking at it. So for now, this is what we're gonna do. We're gonna get the first three main points of a graph. I'll show you what that means. Y equal 3 we know is a horizontal line. If you decided to pick points, you could. If you pick x to be 0, let's say 1 and negative 1. If x equals 0, y equal 3. If x equal 1, y equal 3. No matter what x equal, y equal a 3. If you label 0, 3, 1, 3, and negative 1, 3, and put a line through it, there it is, a horizontal line. Y equal x, if you decided to pick points, notice that these are all functions, so we pick for x. Any function we pick for x. I'm gonna pick x equals, so 0, 1, and negative 1. If I throw a 0 in there, that's a 0. If I throw a 1 for x, y equal 1. And negative 1, y equal negative 1. So I'm gonna pick 3 points per graph in general, but for this first one, to show you how the shape looks like, I'm gonna pick 5 points. And y equal 3 and y equal x, I expect that you know that from what we did already, but let's get to the parts that we don't know. Y equal x squared. So this is how things are gonna work. Every time I get to a graph, if I wanna pick points, I set the inside of the square, the inside of the cube, the inside of the absolute value, or the inside of the radical equal to 0. So where does that equal 0? At 0. I'm gonna move 2 points above it and 2 points below it. Every time I get to a type of an equation I don't know how to graph, I pick points. 5 points normally give you an idea. You're seeing the trend. If you throw a 0 in there, 0 squared is 0. 1 squared is 1. 2 squared is 4. If you throw a negative 1 in there, negative 1 squared is actually positive 1. And negative 2 squared is actually a positive 4. If I plot these points, 0, 0, 1, 1, 2, 1, 2, 3, 4. Negative 1, 1, negative 2, 1, 2, 3, 4. If you connect this with a smooth curve, and why are you connecting this with a smooth curve? You only connect with a straight line when you have a linear equation, when the power and the variables equal exactly 1. This is no longer a 1. Any function that's not linear, you connect the graphs with a smooth curve, and there it is. How about y equal x cubed? The same deal. I'm gonna pick x and y. I'm gonna pick, where does this equal 0? At 0, 1, 2, and negative 1, negative 2. Anytime I come to a relation I don't know how to graph, I pick about 5 points. If I don't see the trend, I pick 7 points. I'll keep on adding points until I see it. If I put a 0 in there, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So 0, 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. It seems, it looks like a parabola. It's a bit more sharp than a parabola. This hits infinity faster than this. It's kind of like this, but through the points, I give you the grid on the exam, so you don't have to worry much about that. When you're graphing this homework, make sure that you're using a ruler to get this right. I want those straight lines. Now, if I pick a negative 1, negative 1 cubed is negative 1. Negative 1 cubed is negative 1. And negative 2 cubed is negative 8. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8. So the graph looks like this negative, the opposite of that. I keep forgetting that I put arrows in this class. So let's get it that way. Here we go. So by not putting anything in this book, they assume there are arrows. They just don't put arrows for some reason. And there's the cubic. Absolute value of x. I'm going to pick 5 points. I'm going to pick 0, 1, 2, negative 1, negative 2. If I put a 0 in there, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. 0, 0, 1, 1, 2, 1, 2. Now, here I'm going to connect those with a straight line. Why is that? Because those are linear. What if I replace x by a negative 1? Absolute value of negative 1 is 1. Negative 2 is 2. So negative 1, 1. Negative 2, 1, 2. If I connect those with a straight edge, that's the graph of an absolute value. When I get to y equal radical x, I gotta be careful because of the domain. So the domain here is that x is bigger than or equal to 0. So if I pick points, I have to pick them positive. I pick 0, 1, I normally pick 2. Is it wise to pick 2 if you have a radical? Since you're picking numbers, don't you think it's best to pick a 4? Because radical 4 is 2. And instead of picking 5, square root of 5 is 2 point some. How about 9? Notice I can't pick negative points because of the domain. So, x equals 0, y equals 0. X equal 1, y equal 1. Sorry about that. X equal 0, y equals 0. X equal 1, y equal 1. X equal 4, square root of 4 is 2. Square root of 9 is 3. So 0, 0, 1, 1, 2, 3, 4, 1, 2, 5, 6, 7, 8, 9, 1, 2, 3. Do keep in mind that this is y equal x to the 1/2. So the power is not 1. You connect this with a smooth curve and there comes your radical. I keep on forgetting. No arrows. I would get used to it. Most books use arrows. This author doesn't like arrows for some reason. And I want to match the back, so they write it this way. You know what? I'm going to put arrows. I'm just so used to it. So these are the basic graphs. Now we want to do some shifting. Do keep in mind, if I pick something I wanted to mention, if I pick 0, a point above and a point below, and I know that the graph of y equal x is a straight line, if I have a parabola and I know what the shape looks like, and I pick 0, a point above and a point below, that gives me the main characteristic of the graph. The cubic, if I pick 0, a point above and a point below, absolute value, if I pick where does it equal 0, a point above and a point below, and again I know the absolute value connects with straight lines, and the only exception is the radical. If I pick 0, the 1, and if I really don't go, I go to really 4 units, I can get these graphs and pretty much figure it out. So I'm going to follow this analogy. Now, I want to sketch the graph of those. So, let's look at the first and pick points. If we pick the right points, we only need to pick 3 points. Where does the inside of this equal 0? Basically, you're trying to figure out those 3 points. Where does the inside equal 0? At 2. If I have a number 9 and there's a 2, a point above it and a point below it will do. Because I know what a graph of an x squared looks like. It looks like this. So a point above 2 would be 3 and a point below 2 will be 1. Again, you would figure out where does this equal 0. Always the inside of a square, the inside of a cube, the inside of an absolute value, the inside of a radical. Where does it equal 0? A point above and a point below. If I throw a 2 in there, 2 minus 2 is 0. If I throw a 3 in there, 3 minus 2 is 1 squared, that's a 1. If I put a 1 in there, I'll get negative 1, but since you're squaring it, you get a 1 as well. Those 3, and this is as accurate as it gets. 0, 2, 0, this is 1, this is 2, 0, 3, 1, 3, 1, and 1, 1, 1, 1. I just labeled those 3 points for you. They're not at the origin. I'm showing you the graph is shifted. So, if you connect this with a smooth curve and you know what a square looks like, guess what? You just got a graph. What if, okay, those swapped on me. I meant to do this last. I want to do this next. Now, as I'm doing this, I'm going to start noticing things because I'm going to come back to this section and do it one more time, slightly different. And that is, I'm going to start using translation without picking any points. For now, I'm going to pick points on every single problem. And when can you do that? Whenever you want. If I look at this problem, say, okay, I know what a square looks like. Let me pick some values. Which values am I going to pick? Where does the inside of this equal 0? Isn't that equal 0 at negative 3? Now, if you have a number line and there's a negative 3, if you pick a point above it, isn't that a negative 2? And a point below it, isn't that a negative 4? Negative 2 and negative 4. That should give you the main characteristics of a parabola, which is where the vertex is. That's called a vertex. If I put a negative 3 right there, that's a 0. If I put a negative 2 in there, negative 2 plus 3 is 1 squared, that's a 1. If I put a negative 4 in there, negative 4 plus 3 is negative 1 squared, that's a 1. So, no need for this. If I plot these points, I'm looking at negative 3, 0. Okay. Here we go. Negative 1, negative 2, negative 3, 0, negative 2, 1, and negative 4, negative 1, negative 2, negative 3, negative 4, 1. And these here where these main points are. If I connect those with a smooth curve, there's my parabola, and this is as accurate as we're going to ever get. Now, I do look at this, say, wait a minute. It seems, actually, you know what? That's fine. Let's just do it that way. Oops. Okay. I was going to talk about translation without graphing, but let's save that for another day. Fully another day. That's okay. Another lecture, I should say, not another day. So here we go. How about here? I get to any graph. I don't know how to do. Well, I know what a square look like. Where would this equal 0? That equals 0 at 2. A point above 2 is 3, and a point below 2 is a 1. That's more than enough for you to sketch the graph of this. Throw a 2 in there. That will be 0 times 3. That's 0. That's a 1. Throw a 3 in there. Wouldn't you get 3 minus 2? That's 1. Squared, that's 1 times 3. That's 3 plus 1. That's a 4. How about a negative 1 right? How about a 1 right there? Isn't 1 minus 2 negative 1 squared? That's a positive 1 times 3. That's 3 plus 1. That's a 4. So we have 2, 1, 1, 2, 1. And 1, 2, 3, 1, 2, 3, 4. And 1, 1, 2, 3, 4. I should have put the other grid. That would have been a lot nicer. No, I didn't think about it enough. I should have put this grid. It would have fit perfect. Okay. And how does that work? You know what? That's okay. we could rescale. That's not a problem. And if I connect those with a smooth curve, this is a sharper graph because of the 3, but there it is. And how about the last problem? How about this problem? Well, I am going to pick points as well. Where does the inside equal 0? That equals 0 at negative 2. A point above negative 2 is negative 1. A point below it is negative 3. That does the trick. Throw a negative 2 in there. That's 0 times negative 2. That's a 0 plus 2. That's a 2. Put a negative 1 right there. That's 1 squared. 1 times negative 2 is negative 2. Plus 2 is a 0. How about a negative 3? Negative 3 plus 2 is negative 1. When you square it, you get a 1 times negative 2. That's negative 2 plus 2, a 0. So, negative 1, negative 2, 1, 2. Negative 1, 0, and negative 3, 0. Now, something's not right. Oh, it wasn't 0, 0. There we go, I'm sorry. So it was negative 1, 0. I was saying this is not symmetric. And negative 3, 0. Now, do you see what happened? I'm looking at this. Normally, those point in that direction. Do you see what the negative did? It kind of reflected those. Well, no big deal. I know how that works. That's the main point. From this point, I connect through the other. And from this point, I connect through the other. And this is a reflected path. So what? 3 points will do the trick. Now, in the next video, I'm going to go ahead and apply this to the rest of those. That is the cubic, the absolute value, and the radical x, and make sure we can graph any of them.